Alright, so Unit 7 Skill 3, how can we prove algebraic identities with rationals and know the difference between prove and solve? We do need to be very careful because they do look pretty much the same, except the key word right at the very beginning, prove. Last class it would say solve, and that's pretty much it, or find x. So prove means we need to get both sides to be the same without bringing terms from one side to the other, and that's the basic gist of it. Okay, so we need to make sure we're not moving things around like we did in the last couple problems, left to right, but we can change them. The idea is to get a common denominator with these proof questions that we're going to be doing, and then just showing that one side is the same as the other. So in this first problem, it starts out the same. We want to get a common denominator. So I have an x cubed plus 8, an x cubed plus 8, and I have nothing. So my LCD is going to be x cubed plus 8. So I'm going to need to multiply by it. So I'm only changing the right-hand side for now. I have to multiply by x cubed plus 8 over x cubed plus 8. So the first part just becomes x cubed plus 8 over x cubed plus 8. And then plus 1 over the x cubed plus 8. Well, my denominator is now the same, so I can combine my numerators. We are not going to drop the denominators this time, but rather combine them. And if you notice, the left-hand side and the right-hand side are exactly the same. That's supposed to be a check mark. Anyways, we're done. That's it. We've now proved it. So what's this little part where it says where x does not equal -2? People never seem to notice it until they actually have to start a problem on their own, so I'm going to point it out now. X equals -2, or cannot equal -2. If you were to plug in -2 right here, it would make the bottom -8 plus 8, which would be 0. So they're saying, prove that this works for every number but x equals -2, because we already know at -2 it makes the bottom 0. So we've now got our proof. They are in fact equal. Let's move on to the next question. Okay, so in this next problem, we want to first factor the denominators to see what the LCD could be. So I have a 4 parentheses a plus 2. Okay, so my LCD is going to have a 4 and an a plus 2 in it. Because on the left-hand side, that's what I have, an a plus 2 and a 4. So works out pretty well. I'm going to need to multiply by 4 over 4 on the left-hand side here. That will make that side have a 4 and an a plus 2. And then the next part is missing the a plus 2. Okay. So I have 4a plus 4 when I multiply it in. The denominator is 4 and then a plus 2. I don't like subtraction, so I'm going to do a plus a negative. So I have plus a negative 3a gets multiplied in, so 3a times a is 3a squared. Negative 3a times 2 is going to give me minus 6a, all over, again, 4 times a plus 2. And that's going to equal whatever it equals, so I got to keep going now. I'm going to combine like terms. Notice my denominator is the same, so I'm just going to write one denominator, 4, and then a plus 2. Okay, so I have a negative 3a squared. I'm going to write that first, because we generally start with the highest power. But I'm going to combine like terms of 4a and negative 6, giving me negative 2a. And then I have a plus 4. Now, some of you may be wondering how these two are going to be the same. Well, there's two things you can do. One, you could take this negative sign here and change the right-hand side, and it's not wrong. Typically, in math, though, we like to stay on one side. So we would take a negative 1 out of this entire left-hand side, the top. So put that negative in front, and then rewrite it. So if I'm going to pull a negative out of all of the numerator, I would have 3a squared that's positive, a positive 2a, and a negative 4. it would be fine if at this stage of the game, right here, you decided, you know, I'm just going to take that negative and multiply it in and see that it becomes this right here, and then say it's good to go. So the way I did it, I kept the negative in front, I pulled it out, and now we have the exact same thing. I could have multiplied the 4 times 8 plus 2 in, I guess, and made it 4a plus 8. I guess I chose not to, so I still kind of manipulated the right-hand side as well. And it's not a big deal, not the end of the world. Both sides are equal, we're good to go. Moving on. Okay, so we look at this first problem. I notice there's a minus sign in there. Might want to change that right off the bat. Maybe not. It's not the end of the world. I think it makes it easier, though. That way we don't screw up later. All right, so let's factor. I have an m plus 5. So my LCD is going to have an m and an m plus 5 minimum, just from the right-hand side. And then over here, there's an extra 3 attached, so I'm going to have that extra 3 too. So I'm going to multiply by whatever is missing. I've got to have a 3m and an m plus 5. Not tons of fun for this problem. So in the left part, I am missing an m plus 5. On the middle part, I am missing a 3m. On this problem, it's a little bit different. I'm actually going to multiply by 3 over 3 and change that right-hand side. So that gives me the 3m. Don't have to do it this way, but I think it makes it a little bit easier. So multiply the 6 in. 6 times the m plus 5 gives me 6m plus 30 over 3m plus 5 plus negative 4 times the 3m is negative 12m over again 3m plus 5. The last part is going to give me 30 minus 6m over again 3m plus 5. So let's combine terms here. I have a 6m and a negative 12m. My denominators are the same, so I can just rewrite that. 3m plus 5. And I have 30 and negative 12 and 6 makes negative 6m. Now, that is the same. That is a check. It works out. Life is good. But this problem could have been solved a little bit differently if I had noticed one thing at the very beginning. So, at the very beginning of it, you see right here I have 6 over 3m. If I would have done the simple thing of divide 6 and 3 and gotten 2 over m, my LCD would just be m plus 5, which is kind of what we have right here. Would have made this question a little bit easier, a little less work, and I definitely wouldn't have had to multiply by this 3 over 3 on the right-hand side. Again, it's okay to do both sides as long as you're not moving things from one side of the equation over to the other, right, moving it back and forth. We can't do that, but you can work on both sides. One other thing that we could have done in this problem, if we got our common denominator the way we were doing it, and not having to multiply by the 3 over 3 here, would be to take this guy right here and realize that we could divide everything by 3, the 30, the 6, and the 3, and that would reduce. 30 divided by 3 would become the 10, 6 divided by 3 would become the 2, and 3m divided by 3, this whole thing, 3's would cancel, would become m plus 5. So I guess there's 3 ways that we could technically have solved this one. You know, whichever way you tend to see it is fine. It doesn't really matter. So let's move on to that next question, which starts out really weird. You know, and let's just take a look at this and see how we can manipulate it and show that the right-hand side equals the left. So I notice the denominator is the same, so it looks a lot easier. So let's just go ahead and combine. I don't like that negative. That negative is going to throw people off pretty consistently, so I'm going to do plus, and I'm going to put a negative 1 in front of the whole thing so that I know to multiply that negative in. So this will become m minus 4 over 6m minus 6 plus negative m minus 5 over 6m minus 6. We're trying to show it equals the other side. So my numerators here, pretty straightforward, pretty easy. I can add the m and the negative m, they cancel. And then when I add my negative 4 and negative 5, I end up with a negative 9. So I get negative 9 over a common denominator of 6m minus 6. Except my goal is to show here, not that it's 6m minus 6, but that it becomes 2 and m minus 2. Well, just like I talked about in this last question up here, we can divide the 9, the 6, and the 6 all by a constant. That constant would be 3. And when we do so, it ends up working out in our favor. So we'll divide it by 3. Okay, taking a 3 out of each of them, so it's negative 3 over 2m minus 2, which is equal to negative of 3 over 2m minus 2. That is the same. That's a check. And we're good to go. Next problem. Okay, question 5 is thrown in here just to mess with you a little bit. See the key word here that says solve? Notice that it doesn't look a whole heck of a lot different from the previous question, so you got to be careful. You have to make sure you're paying attention to the word solve versus prove, and then you won't do the wrong thing. So in this case, so we factor again, still finding that LCD, which is x minus 4. Okay, so I'm just missing the x minus 4 on the right-hand side. So I'm going to multiply by x minus 4 over x minus 4. Okay, so the left-hand side becomes 1 over x minus 4. I'm going to do plus and negative of the whole thing up here. So it becomes negative 4x plus 1. So I don't mess that up later, just take care of it now. Equals, and it's going to be x plus 7 multiplied by x minus 4 over x minus 4. So the right-hand side is not so much fun on this particular question. We actually have to do a bit of work. Left-hand side, it's kind of nice. We're going to drop the denominators and write 1 plus negative 4x plus 1 equals, we have to FOIL out the other top, x squared plus, sorry, it's going to be minus 4x first, plus 7x minus 28. We'll combine like terms on each side to get negative 4x plus 2. On the other side, or x squared plus 3x plus 28. Minus 28, apologize. Get it all set equal to 0. So add 4x over, subtract 2, we get 0 equals x squared. So adding 4 to 3 gives us 7x. Subtracting 2 from negative 28 gives us negative 30. Hopefully that's going to work out with that multiply. So 0 equals, it looks like 10 and 3. Plus 10 minus 3 will add to positive 7 and multiply negative 30. So I get x equals negative 10 and x equals 3. Okay, so the only values that we reject are values that make the denominator 0. There are only two values that would do that, if x was 0 or if x was 4. We didn't get either of those, which is very rare. The Regents does not normally do a question like this. There's almost always at least one reject. Alright, don't forget to write your summary, do your practice problems, and show us. Thank you.